Well, what's up, everybody? Got another video here for you. Some growth and decay problems. This one is dealing with Newton's law of cooling. So it says a cup of coffee cools according to Newton's law of cooling. We have T of T is equal to T sub S plus T naught minus T sub S times e to the negative kt, where T of T is the temperature at time t in minutes. T sub S is the surrounding temperature, so that would be like the temperature of the room and stuff. T naught is the initial temperature, and K is a constant. If the coffee starts at 90 degrees Celsius, okay, so let's write down the information as we go. So that tells us T naught is equal to 90. Okay, 90 degrees Celsius. And the room is 20 degrees Celsius, so that's the surrounding temperature. So we've got T sub S is equal to 20 degrees Celsius. And the coffee cools to 60 degrees Celsius in 10 minutes. So remember, T of T, T sub T, that tells you that's the temperature. And the 10 minutes, if you plug that in for T, so in other words, if we plug 10 in for little t, we should get 60 as an answer. So what that's telling us is that T of 10 is equal to 60 degrees Celsius. All right, so, well, if you look at this, they want to know, find the time when the coffee reaches 30 degrees Celsius. Okay, so in order to work this, we need to know what T sub S and T sub naught is, and T naught and T sub S. And we also need to figure out what K is. Okay, let's plug in all the information we have so far. Okay, so we have T of 10 is equal to, what is that? 20 plus 90 minus 20 times e to the negative k. And remember, the 10, we're plugging that in for the lowercase t. And when we plug all that in, we should get 60 as an answer. So basically what it is, when you plug the 10 in for the lowercase t, you should get 60 in it, 60 as an answer. Okay. All right. So that basically, that's going to give us, whoops, let me switch colors back. That's going to give us 20 plus 70e to the negative 10k is equal to 60. All right. So you got the 90 minus 20, that's where the 70 comes from. And so basically what we have to do here is solve for K. So if I subtract 20 to both sides, I'm going to get 70e to the negative 10k is equal to 40. And then I'm going to divide both sides by 70. And so that gives me e to the negative 10k is equal to 4 over 7. So we've got to solve this for k. So in order to do that, I'm going to take the natural log of both sides. All right, and this is going to give us negative 10k is equal to natural log of 4 over 7. All right, now, the thing that you might be wondering is, how in the world did you get negative 10k? What happened to ln and e? Well, let me show you. So these go back to properties of logarithms. So we know the log of b to the x with base b is equal to x. In other words, if the base of your exponent and the base of the log are the same, then your answer is your exponent. And then we also know that natural log x is the same thing as log of x with base e. So basically what we're doing, instead of writing out log base e, we abbreviate it with ln. ln is the same thing as log base e. So what we had over here is we had natural log e to the negative 10k, which, remember, that's the same thing as log of e to the negative 10k with base e. And since the base of the exponent and the base of the log are the same, you get negative 10k. And that's where that negative 10k comes from. So now we're going to divide both sides by negative 10. So we get k is equal to the natural log of 4 over 7 divided by negative 10. And if we punch that into our calculator, we get you get 0.055961579. And what I'm going to do is I'm going to just round this to 0.056. The actual answer in the calculator is 0.055961579, but I'm going to round it to 0.056. So now what we get is so remember, we have t of t is equal to t sub s plus t naught minus t sub s e to the negative, is it negative k? Yeah, negative kt. All right, so plug everything in. You get t of t is equal to t sub s, and we can see t sub s is 20. Okay, t sub s is 20 and t naught is 90. So that's going to be 20 plus, and that's going to be 90 minus 20 e to the negative 0.056 t, which means t sub t is equal to 20 plus 70 e to the negative 0.056 t. That's our function there. See, the only variable we have now is t. That's what we were wanting to get. Now, what do they want to know? They want to know, find the time when the coffee reaches 30 degrees Celsius. So we want to know, when does 20... All right, well, let's do this. We want to know when t is equal to 30. That's what we're looking for. So in other words, when does 20 plus 70 e to the negative 0.056 t equal 30? And so now we got to solve this for t. So I'm going to subtract 20 to both sides. So I get 70 e to the negative 0.056 t is equal to 10. And then I'm going to divide both sides by 70. And so that's going to give me e to the negative 0.056 t is equal to 1/7. All right. Now, to solve this, we're going to solve it just like we did this one up here. We took the natural log of both sides. So I've got natural log e to the negative 0.056 t is equal to the natural log of 1/7. So this is negative 0.056 t. Remember, I explained earlier how that works. Is equal to natural log of 1/7. And so then we're going to divide everything by negative 0.056. and I'm going to get T is equal to, and we will punch this into our calculator, natural log 1 divided by 7 divided by negative 0.056. And that gives us 34.75 when we round it. And let's see, T, we got to see what T, little t is in minutes. So that's going to be minutes. So that's how long it'll take for the coffee to reach 30 degrees Celsius. All right, so I hope you enjoyed that video. Hope you learned something. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.